Hello everyone and welcome to Guru Squad. My name is Ahmed. I'm going to be showing you today how GS RichCopy 360 multi-threading technology is way different from all the other competitors. Additionally, I'll be showing you a full demonstration of how GS RichCopy 360 multi-threading technology can increase your copying jobs in speed and performance by probably tenfold or more, depending on the files you're copying. Here, in this example, or in this slide, we've got a computer, or a server, with two CPUs, dual core each, so that's a total of 4 cores, and we're going to copy files from the source to the destination. But in this example, we're going to be single-threaded. In a single-threaded copying job, files basically go sequentially, one at a time, using core 0, where core 1, 2, and 3 are going to be sitting idle. Of course, what this does is it makes the copying take a long time because it's going sequentially. If you have a large file, that large file is going to serve as a bottleneck on core 0 where the rest of the files are waiting. As a result of this copying, what happens is CPU resources are going to be underutilized since you're only using core 0. The rest of the cores are sitting idle. It's not a scalable solution. Inefficient way of using available resources because you've got other resources that are sitting idle, and the copying time is going to be the longest. Where if we start looking at multi-thread technology offered by our competitors, notice we've got the same example, 2 CPUs with 2 cores each. If you start the copying job, all the files, if you've got 4 threads, they're going to go to core 0. Core 0 in that sense jumps up to, could be 60%. And then the next batch of 4 jobs come in and they copy. Also, in this case, core 1, 2, and 3 were sitting idle. Core 0 is the only one that's working, and it spiked up. The reason of the spike, not just because of the files that it's copying, but it causes, when you've got multiple processes hitting the CPU at the same time, the core 0 can suffer from CPU contention. So the wait time is going to increase. So in that case, we've got CPU contention. It's obviously not a scalable solution. If you've got 12 cores or 32 cores, core 0 is the only one that's involved. Performance can be degraded, especially if you've got other applications running who are also written to only use core 0. Which is very much the case in a lot of applications. And this is an inefficient way of using available resources because you've got core 1, 2, and 3 sitting idle. And it does take a longer time to copy. Of course, it's faster than using a single-threaded job. Now, this example was our competitors. Now, let's go ahead and look at what GS RichCopy 360 multi-threading technology looks like. We've got the same exact example. We've got 4 cores total, and we're going to do also 4 threads. When we start copying, each core is going to get a file to copy, so the jobs are evenly distributed on all logical cores. This of course results in robust performance, it's a scalable solution, and there is no CPU contention whatsoever. As a result, we've got a balanced CPU workload. If you've got more cores available, it's going to be very scalable. You can do more and more threads. We support up to 256 threads. Efficient way of using available resources, and of course this is the shortest time to copy. In conclusion, just to give you an idea of some benchmark results that we've had third-party tester test. If you've got a single-threaded job that takes about 2 minutes and 39 seconds to complete, our competitor's multi-threading technology with 8 threads would take 1 minute and 15 seconds. This is roughly, half the time, which is very good. However, if you do look at GS RichCopy 360 multi-threading technology, the same job with 8 threads as well, it will take only 29 seconds. And that's a huge difference between single-threaded and multi-threaded from GS RichCopy. And this is even less than half of what our competitors' multi-thread technology would use. Let's go ahead and look at an example. This is GS RichCopy. We're going to go ahead and double click. These are the different jobs that are available. We're going to look at the first job here. We're going to copy files from the D drive, software distribution, and we're going to copy it to G drive, software distribution. So we're going from D to G locally. And we're going to copy files only. We're going to do copy files only. And in this case, we're going to set it from 4 threads to just a single thread, just to give you an example of how long a single thread would take. I'm going to go ahead and right click here and start the job. We can click start right here. It's getting queued up and it's running right now. If you click on running, it will show us the copying job as it runs. At this point, because we only have one single threaded, we only see one process that's copying. I'm going to go ahead and pause it because it says here that it's going to take about a minute or so. So I'll pause it, but once it's getting close to copying, notice that we've got a number of files, 1,717 files to copy. I'm going to pause it before it ends. It's at 44% now. I'll let you see the rest. Alright, so now I've resumed the recording. The files I'm copying, so far it's taking 2 minutes and 20 seconds. This is with a single thread. After this, I'm going to show you multi-threaded through GS RichCopy with 8 threads. So the whole job, it took to copy 597 megabytes of 1,717 files. It took about 2 minutes and 25 seconds. So that's our magical number. Now let's look at a job, the same exact job. This is the destination. I'm going to go ahead and delete the destination so we can recopy it, but with the 8 threads. So I'm going to go back to the same job. I'm going to change the copy threads from 1 to 8. Now we're going to go ahead and start the job all over again. It's going from source here to destination right here. So we can click here to look at the progress, or we can click on progress down here. You notice this is the job started copying. 1,717 files, 597 megs. And you look down here, you could see all the threads that are running. So far it's 24 seconds. And it finished the job in 27 seconds as opposed to 2 minutes and 25 seconds. This is a remarkable number. These are different threads. Each thread was assigned to a logical core. Thank you very much for viewing, and I hope you've noticed the power of GS RichCopy 360 multi-threading technology.